Now pretty much every way that I know to make a tenon results in a tenon with square edges. Now if you make your mortises with a router, that means you are quite literally trying to fit a square peg into a round hole. Now usually we just dog ear the corners and it fits okay, but what if we could make square holes to begin with? Well, that's what a hollow chisel mortiser is all about.
The Hollow Chisel Mortiser makes quick work of the repetitive task of making mortises. Within seconds, you can produce perfectly square mortises in any species of wood.
Now this beautiful behemoth over here is my Powermatic 720 HD. Frankly, it's a little bit overkill for most shops, but if you run a pro shop, you know as well as I do that time is money. And if you've got 50 to 100 mortises to batch out, you're going to be thankful that you've got a machine like this. The operation is fairly straightforward. You've got a nice flat table and a head that moves up and down and drives the bit into the work. In fact, it's very similar to another tool that most of us probably have in our shops, and that's a drill press. The key difference here, though, is the bit itself. The drill press is just running a straight circular bit into the work and creating a circular hole. But somehow we're able to create a square hole here at the Hollow Chisel Mortiser. So the magic is the chisel and bit combination. And let me show you what one of those looks like. Now this is a 1-inch chisel and bit set, and frankly this is bigger than I've ever needed in my work, but it came with the mortiser, so I've got it for demonstration purposes. You've got a 4-sided chisel here with an auger bit inside. Pretty standard as far as auger bits go, but it's sized perfectly to fit inside the 4-sided chisel. Okay. Now the machine is going to be spinning this bit, and it removes a circular column of material, and then the chisel comes up behind it to square everything off. So what might be a little bit of a surprise the first time you use a hollow chisel mortiser is the fact that it's really your manual power that's driving this chisel through the wood. So the harder the wood, typically the more difficult it is to plunge down into the work, because all the machine is doing is removing a single column of material. But when it's all said and done, you get a relatively clean mortise. And in fact, here's an example of a mortise cut with a hollow chisel mortiser. Now if we open this up, you'll see on the inside, it's not a super clean wall, certainly not as clean as you might expect with a router, but it doesn't necessarily need to be absolutely perfect. And the better you set this machine up, the cleaner this wall is. Now down at the bottom, you're always going to have a little bit of schmutz down there because just the way the machine is built, the chisel and bit, the way they work together, you're always going to have a hole that's a little bit deeper and some extra material behind it that the chisel just missed. So basically when you set your depth, you take that into account. And you can always come back with a chisel and remove some of this extra material if you want to get a little bit more depth out of your mortise.
Mortisers come in 2 different form factors, benchtop and floor standing. Benchtop versions are great entry-level tools that will get the job done most times. The problem is, they can be a little bit underpowered on some hardwoods, and the tables and fences are not quite adequate for larger workpieces. Benchtop mortisers range in price from $250 to $450, and they typically sport half horsepower to 3/4 horsepower motors. Floor standing versions are more expensive than their benchtop counterparts, but you get a lot more for your money. Heavy-duty construction, more power, larger movable tables, and better clamping options make all the difference in the world. They range in price from $800 to $1,000, with some heavy-duty models going over $2,000. And in most cases, they range from 1 horsepower to 2 horsepower, and that's plenty of power for even the densest hardwoods.
When shopping for a hollow chisel mortiser, whether it's floor standing or benchtop, there are some key features that you should consider. Vertical travel basically means how far up and down the head of the mortiser can go. And of course, more travel means that you can fit larger work pieces underneath and you can make deeper mortises. A depth stop is vitally important in making sure that your mortise is an even depth all the way across, so that each time you plunge down, this stop bottoms out and it makes sure that the bit doesn't go any further than you want it to. And if you can, try and find one that has measurements on the side, and that actually makes your life a little bit easier. A good clamping system is incredibly important. Obviously, we don't want the workpiece to move. That's kind of a no-brainer. But what most people don't realize is after you plunge into the work, when you try to pull that bit back out, there's a lot of friction there, and you can pull the workpiece up with you. So if you don't have good clamping pressure, that's definitely going to be an issue. Sometimes you may see units that have two fingers that clamp down on the top of the workpiece, and they are there specifically for that, to help resist the workpiece rising up as you pull the bit out of the work. Built-in stops are a real nice luxury to have. This way you could register your workpiece up against the stop and know that you're registering in exactly the same spot every single time. Now with the arm on the mortiser, there's a couple things that you want to consider. First of all is the length and the shape of the handle. Some have a nice sort of L-shaped handle, which is a little easier to grip, and some come a little bit shorter than this. The thing is, it's all about leverage. So the longer the handle, the easier it's going to be to pull down into the work. Another thing you want to consider is the angle. Is there an easy way to adjust the angle? Because depending on the workpiece and the range of motion that you need, sometimes having the handle all the way back here is a little bit inconvenient. It's very hard to reach that. So on this particular model, we can pull the handle out and adjust it to a preset stop that's a little bit further. So this way you have a nice range of options no matter how big the workpiece is and no matter how deep your mortise is. Now one feature that's really nice to have, but you typically only find it on the floor standing units, is either a tilting head or a tilting table in case you ever need to make a mortise at an angle. Now this particular model uses the tilting table option. Let me show you what that mechanism looks like. So I've got a full range of motion from 45 degrees one way to 45 degrees the other way. And once you have the angle you want, you lock down the first lever and then lock down the second lever, which is more like a security lock to make sure nothing moves. Now another killer feature that you're really only going to find in these larger units is either a movable table or a movable head. And the reason we want this is primarily speed, convenience, and accuracy. If you don't have that, you have to unclamp the workpiece, move it, and then clamp it back in place, and then finally plunge down again, and you sort of repeat that process over and over. With a movable head or a movable table, you're just pulling on a lever or turning a wheel to adjust the position of the workpiece relative to the chisel. So you can move a lot faster and it's a lot more accurate, but again, it's really only something you're going to find on these bigger machines. Now on my mortiser, the head is what moves, and this lever on the side moves the head front to back, and this big monster lever is what moves the head side to side. We also have adjustable stops that you can move one way or the other to limit the motion from side to side and front to back, and this allows you to have a perfectly repeatable mortise no matter what the dimension is. Now if you want consistent and repeatable results with your mortiser, you have to set it up properly. I'm going to show you how. The first order of business is to make sure that this chisel is running straight and true. So we want to make sure that the table is perfectly perpendicular to the chisel in the side dimension as well as the front to back dimension. So let's test those separately. First of all, side to side. And you can see I'm a little bit out at the top here, and frankly I would guess that that's because I was just messing with the table tilt. So it's a very easy fix. So I'm going to keep the square up against the chisel and slowly tilt the table until there's no more gap. Looks good. Tighten it up. Now for front to back measurement, just put the square up against the front or the back of the chisel. And really we're focusing on this bottom portion here. Some of these chisels tend to bow in a little bit, especially where the chip ejection slot is. So I'm really only concerned about this bottom ½ inch, 3/4 of an inch or so. That looks pretty much dead on. Now if it wasn't, you have a couple options. Our table here actually has an MDF auxiliary surface. It's kind of a sacrificial surface that can be replaced if need be. But we can also take these screws out and put in very, very thin shims. You might even just use a couple layers of masking tape to tilt the table one way or the other, and that could very well adjust for any discrepancies that you see front to back. Now, a more permanent solution that's going to vary from brand to brand and model to model is to potentially shim the entire top portion here. So you might be able to loosen these screws and add, maybe little automotive shims, little brass shims to get the top to tilt in the perfect orientation. Now, of course, we can't forget that the fence needs to also be perpendicular to the table surface. Now, one of the most common things that people mess up when setting up their mortiser is the relationship of the bit to the chisel. A lot of people will just put that bit right up into the bevel of the chisel. And what that does is it creates a lot of friction and heat. So eventually you'll wind up just snapping these sharp points right off and you'll dull your bit very quickly. That extra heat is just not good for metal. Not to mention, if the wood is hard, it's going to be nearly impossible to plunge this down. So what you really need to do is have the bit lead the chisel a little bit. So it has to protrude just a little bit. This is not really an intuitive thing. So when you set it up at the mortiser, you got to know exactly what to do to make sure that the bit is in the exact position that you want it to be in. So let me show you the tricks to making that happen. Just as a safety precaution, it's always a good idea to wear a glove when you do this because you're going to be touching these sharp spurs and little points of the chisel here, and that can very easily put a hole in your fingertip. You don't necessarily need 2 gloves for this. You can just go Michael Jackson style. And I think I just dated myself. The auger bit is held in with a pretty standard drill press chuck, so I can just loosen that up. So you'll see that the auger bit just slides right out. And what you'll notice is that the bit is held separately from the chisel. The chisel is held in this area here, and the bit is held by the chuck. So we're going to use that to our advantage to make sure that they are set in the proper relationship to one another. Now to loosen the chisel, I just use an Allen wrench. There's a little set screw in here. And the chisel pops right out. So I'm going to reassemble everything now, and we're going to calibrate it as we go. So push the chisel and bit all the way up. Of course, you want to make sure that the bit goes into the chuck and that your chisel goes into this collar, this little sleeve here. So the trick to making this work properly is to put a little bit of a gap between the chisel and the sleeve, and you'll see how this resolves in a little bit. That gap is going to be exactly the distance that we want between our chisel and our bit. Now, if you don't have little shims or feeler gauges that you can use for this, you can even use a card scraper. Okay, it's nice, it's metal, it's fairly thin. This is about a 1/16 of an inch. If you want to go a little bit thicker, use 2 of them. So I'm just going to use one as a 1/16 of an inch shim, and I'm going to put it right on top of this chisel's shoulder right here. And then I want to push it all the way up so it holds the shim in place. Everything is up as far as it can go, and that shim is wedged in between the chisel and the collar. Now, while holding everything in place, use your finger, or if you want, if your fingers are hurting, use a piece of scrap wood to make sure that that auger bit is pushed as far as it can go. And then we're going to tighten the bit in place. And once the bit's locked down, you can remove your shim. Now here's where the magic happens. The gap that's up here, that 1/16 of an inch gap, gets transferred to the bottom as soon as we push the chisel up. And now that bit is leading the chisel by a 1/16 of an inch. So all we need to do is tighten down the chisel in place. And now we have the exact distance that we wanted between our chisel and the bit. Now the chisel to bit distance is something that is actually going to change depending on the size of the bit and the hardness of the wood. So there really are no hard and fast rules, but I do have some general guidelines for you that should help you get started on the right foot. Oh!
In softer woods, things like poplar, pine, alder, and cherry use a 1/32 inch spacer when using a 1/4 inch to 3/8 of an inch chisel. If you're using a 1/2 inch chisel or larger, use a 1/16 of an inch to 3/32 of an inch spacer. In harder woods like oak, birch, maple, and some exotics, use a 1/16 inch spacer when working with 1/4 inch to 3/8 inch chisels. If using a 1/2 inch chisel or larger, use a 3/32 of an inch to an 1/8 inch spacer. Many times, you can tell just by looking whether the chisel is set up properly. This one is not. Good? Bad. Bueno? No es bueno.
Now the next thing we need to set up is the orientation of the chisel itself. We want to make sure that the front and back faces are perfectly parallel with the fence. If they're not, what we wind up doing is getting slightly skewed square holes. And in fact, I want to do a test cut here because I know that this chisel is out of alignment, and I want to show you what it looks like to sort of exaggerate that problem so you could see how awful that would be on a finished piece. So you can see what it creates is this sort of stepped pattern is each time we plunge, we're slightly skewed. Okay, and this is really not going to provide a very good fit for your tenon. So let's set this up properly so we can get perfect results. Now first things first, we want to loosen the chisel. And don't worry about that height adjustment that we made before. That's still going to be intact. As long as this chisel is pushed all the way up, we don't have to worry about that. We're free to sort of move the chisel back and forth this way until we find the perfect orientation. Now some folks, and most setup procedures I've seen, usually recommend that you use a jointed piece of stock between the fence and the bit. And you want to basically just move the head or move the fence so that the bit is right up against the workpiece. Okay, and you can see I have to move my little lever back here. Okay, and until there's no play left back and forth, you see I can't even really move it. At that point, you want to tighten it down, and that should be pretty darn close to perfect. But for me personally, I actually like to use the fence itself because there's some variability in here. If this face of this board was not perfectly parallel to its other face, you could get a little bit of a skew there. So I like to use the fence itself. So to do that, I just bring the head back, or your fence forward if your fence is movable. And you see how I kind of rotate it back and forth. Do the same thing I did with the wood, only I feel a little bit more confident when I go metal to metal like this. Getting closer. And here, at this point, you can see I don't have any more movement. Now I'm not putting a lot of pressure because I don't want to bend anything. I just want to make sure that there's no movement there. And at that point, we can tighten it up. And now we can see, since there's no play here, we know that this chisel is perfectly parallel with the fence. That's exactly what we want. Let's do a test cut. And there you go. Huge difference between the first cut that we did and the second cut. Now I never expect those walls to be absolutely perfect, but that's probably about as close as you can get with a hollow chisel mortiser. Now there is one more aspect to setting up the chisel that you need to think about, and that's the orientation of this relief slot. This is where all the chips come out. Now the reason I didn't talk about it yet is because it's pretty much tied into your personal method for how you approach making these mortises. And from the way I see it, there are two ways. I'm going to show you both ways, but one of them is a little bit more, well, let's say it produces better results in the work, but it's a little bit harder on the tooling because you have a little bit more heat buildup. The other method is a little bit easier on the tooling because there's less heat, but you may wind up with slightly lower quality results. So let me show you the two methods.
The first involves plunging into the wood and making subsequent cuts one chisel width at a time. By orienting the relief slot toward the area that's already been cut, the chips eject easily and you have less heat buildup. The problem is that during each one of these cuts, the chisel is unsupported on one side, and it has a tendency to deflect. The second method is what I call the no deflection method. I start by making a cut at each end of my mortise, and then stagger each cut thereafter, leaving a little bit of connecting material in between. Each time we plunge, the chisel is supported on all four sides and will not deflect at all. The remaining connecting material is easy enough to remove.
Now I'm definitely in favor of the no deflection method. The bottom line is whatever gives me the best results for my projects is what I'm going to use, even if it means that I'm putting a little more wear and tear on my tools. But also keep in mind that the other method, even though it seems like it's better for the tool because it's not building up as much heat, that deflection that occurs if there's not support on all four sides of the chisel, that can lead to problems too, because now we're actually forcing the chisel out of a straight position, which really isn't good for the long run either. So the bottom line is, for me personally, the no deflection method is the best way to go, and the way that I fight the heat buildup is to just have really, really sharp tools. That's the next thing we're going to focus on. Let's sharpen up a mortising bit and chisel. So I'm going to start by touching up the auger bit. Generally speaking, I don't do this very often, and frankly, the less material you remove from a bit, the better. I really just do it to do a little bit of touch-up here and there. So let me show you the process. Now, if you want, you can use a specific file for this. They actually do have auger bit files, and you probably have some files in the drawer that would work. But I really prefer to go a little bit lighter, and I use these little diamond honing plates. And they're on a nice little plastic stick. It's very easy to get in here. You could sharpen router bits this way. And for something like this, I find this to be perfect, and it's not very aggressive, which is good because I just don't want to remove a whole lot of material. So I'm going to go with the super fine, and we'll do a little touch-up work. Now I'm really only going to focus on my cutting surfaces, and you want to be careful not to change the dimensions of the bit. So we have to keep that in mind as we go. So here's one area that can use a little touching up. That's this bevel right there. So I'm just going to take the honing plate. I don't really want to change that bevel angle. I just want to clean it up a little bit. And if you want, you could certainly put a little bit of water on there. Help things go a little smoother. Okay, that's looking pretty good. Okay, now if you feel a significant burr developing here, you may want to just take a quick pass or two, but you really don't want to work that underside too much. Just focus on the bevel of the cutting edge here. That's looking pretty good. Now you have another spur that runs around and helps keep the hole nice and circular, so it sort of severs material on the outside edge as this piece is just kind of peeling it away. So we do want to make sure that this inside surface gets a little activity here. And now this shape should be a little bit concave, so it's really not the end of the world if you do short strokes, just to make sure that you sort of maintain that concave shape. You don't necessarily want to flatten it out, which eventually you could very well do if you keep doing long strokes across both of the high points. Now the final thing we want to address is the center spur. You basically have three faces and they're all nice and flat, so it's fairly easy to clean those up. Just a little bit of touch up like that. Now, one thing you want to avoid doing is working the outside edge. Think about it. If you start removing material from the outside here, what are you going to do? Well, you're going to change the effective diameter of this cutting surface. So only inside edges and cutting edges, and you should be fine. Now for the chisels, you want to treat this surface like you would the back of any chisel. We want to make sure that it's nice and flat and clean. And if you remove all of those machine milling marks, you'll find that the chisel is much easier to pull out of the work after you plunge it in. So depending on the sort of level of scratches you have here from the manufacturer sort of determines what grit you need to start with. But most times I find that I don't need to go any lower than 1,000 grit. So that's what I have here, just 1,000 grit water stone. In fact, this is a Sharpening ceramic stone. And I'm going to give a couple passes on each face. Now I only really work the bottom because at least the chisels that I have access to, most of them dip in just slightly. So the business end, okay, this bottom ½ inch is really the thing you're most concerned about being nice and flat. And if you work it too much, you could very well change the orientation so it's out of square. That would be bad news. So just put pressure down with my index finger, move it forward and back. And in no time, you should start to see it taking up a nice shine as you go. Okay, I'll polish that up just a little bit more. Now you can see most of the factory mill marks are gone. I just have this little tiny bit here. But if you look down at the tip, it's pretty much clean from point to point all the way around that surface, and that's really the most important thing. I'm really not too concerned about this. You can work it a little bit more if you want to. I just don't feel the need to do that, and I think this helps to maintain the integrity of the original size of this chisel. If I push it too much, I can actually change its dimension, which is no good. So I'm going to do the same treatment on the other three faces. And once all four faces are done, I'm going to move to my 5,000 grit stone. And I really am treating this pretty much like a regular chisel. Just polish up each face. Now the outside faces of our chisel are nice and polished up to 5,000 grit, but as we know with chisels, that's only half the battle because we have a bevel that needs to be sharpened on the inside. And unlike a regular flat chisel, this bevel is a little bit more complicated. How the heck are we going to sharpen that? Well, fortunately, there are some things out there that are made solely for this purpose. So let me get the chisel mounted into the vise. Try to get it as close to vertical as you can. And here is one such kit. Basically, it comes with a handle and two cone-shaped diamond sharpeners. And these are meant to fit down inside the chisel, and you just kind of spin them around and it sharpens it up. You've got what they call one that's basically coarse and the other is fine. So use the fine if you have to. If you don't see much progress, you might want to switch to the coarse, but I always like to use the fine first because I don't want to remove any more material than is necessary. So once you have the one you want, pop it into the little handle here. Now your goal is to spin the cone, sharpen the interior bevel, while trying to keep everything as perfectly vertical as possible. And that's really the challenge with this particular setup. And let me show you the second option, because I think that one is a little bit better. Now this one works in a very similar way. You can see I have this sort of conical shaped sharpening element here, but the difference is I have these little pilots that will go into the hole on the front. And that actually will help not only guide this, but help me stay perfectly vertical. So I've got a 3/8 inch chisel here. I'm gonna pop in a 3/8 pilot and tighten the little set screw. And it does recommend in the instructions that you do this by hand and do not use a drill, so I'm just gonna use the little handle from the other kit. And now I just drop the pilot in place, and that actually is going to go a long way in helping me keep this perfectly vertical. So how do you know you're finished? It's actually pretty easy. Just use your fingers to feel the edges, and if you feel a little metal burr there, that means that the metal has been honed enough that it's actually folding over the edge a little bit. And I definitely have a burr on all four sides. So let's head back to the 5,000 grit stone and we'll remove that burr. Now removing the burr takes almost no effort at all. Just about 3 strokes per side should be enough. And if you feel it with your fingers, there shouldn't be anything there anymore. Now the good news is that process that I just showed you is what you do with a chisel that's straight from the factory. It needs a little bit more work than one that we've already honed. So in the future, when this chisel becomes dull, I'll take it back to the bench. I will start by honing the bevel on the inside. That's going to create that burr along the outside edge. So I'm just going to take it from there to my 5,000 grit stone, polish up the outside edges, and the chisel is done. So it's much easier once you do this the first time with the factory chisel. Now as a final preventative measure, I like to use a silicone-free dry lubricant on both the bit and the chisel. It basically goes on wet and then dries a couple seconds later. You can wipe off the excess. And that will keep this bit nice and lubricated and a lot less likely to sort of gunk up with wood chips. Now to maintain the mortiser itself, I recommend using some form of lubricant on any moving part. So that means the dovetail ways, if you have any gears or things like that, you just want to keep them well lubricated. And you kind of have 2 choices. I usually recommend either white lithium grease or a dry lubricant. Now here's the thing, the white lithium grease is probably going to lubricate better. The drawback is it tends to catch more dust and debris, whereas the dry lubricant, maybe it doesn't lubricate as well, but you're less likely to accumulate dust and that gook that sort of gets around anything that's oil-based and lubricated in the shop. So for me, I like the dry stuff a little bit better, and I like to spray a little bit on any spot where there's metal to metal contact, and that should help it move nice and smooth. So that, in a nutshell, is the Hollow Chisel Mortiser. It is a heck of a tool. Now, depending on your budget, depending on the amount of space you have in your shop, you may or may not think that this is a worthwhile purchase because it really only does one task. And think about it, there are other tools out there that we use to cut mortises that also do a ton of other things. For instance, the router. So a lot of times the router is a more sensible choice when you're first starting out and stocking up your shop. But if you get to the point that you need to batch out a bunch of mortises quickly, you want to do it in a way that's very easy and repeatable, you just can't beat a Hollow Chisel Mortiser. It's definitely a good option that you should check out. Thanks for watching, and we'll catch you next time.